This is 8.2, day 1, part 3. We just have a couple problems left where we want to divide this rational expression. So we have x squared minus 36 over x. And then we're dividing it by x cubed minus 6x squared over x squared plus 6. So if you remember from the last video that if we have division, we change the sign to multiplication, and then we flip or reciprocate the second fraction. So we're going to keep the first fraction. We're going to change division to multiplication. And then we're going to reciprocate. So my x squared plus x goes on the top. And then my x cubed minus 6x squared goes on the bottom, on the denominator. Now the next step is to go and see if we can factor these polynomials. So the numerator of x squared minus 36 can be factored using the difference of two squareds, x minus 6, x plus 6, and then all over x. In the second fraction, its numerator has a GCF. So we can take out an x, and we're left with x plus 1. In the denominator, we have another GCF of x squared. We can be left with x minus 6. So now before we multiply, we see if we can cancel anything. We have a common factor of x minus 6. We have another common factor of x. So then our final answer, what's left is x plus 6 over x plus 1 all over x squared. For our class, we don't have to go and FOIL out that numerator of x plus 6, x plus 1. Just leave it alone. We do want you to identify that domain restriction again. So the domain restriction is, what can x not be? So we're trying to think of when would the denominator equal 0? What makes it undefined? Well, if I put a 0 in there or in here, it makes it undefined. So x cannot be 0. The other piece is if I substitute a 6 into there, it would also make that undefined. So x cannot be 0 or 6 in this problem. Last example. Another dividing rational expressions. We have x minus 4 over x minus 2 all squared divided by x squared minus 3x minus 4 over x squared minus 4. So again, we're going to keep the first fraction, change the division to multiplication, and then reciprocate or flip that second fraction. So we keep I'm just going to split this up as x minus 2 and x minus 2. And then multiplication is now changed as the sign. And now we flip. So now it's x squared minus 4 in the numerator. And then x squared minus 3x minus 4 in the denominator. Now we want to factor. Well, the first fraction is already factored, so that's still just x minus 4. X minus 2, x minus 2. The second fraction, the numerator, is difference of two squareds. So we have x minus 2 and x plus 2. Then the denominator, we want to factor that. Well, that's going to be using the t-chart. So we say, what are the factors of negative 4 that add to negative 3? Well, negative 4 times 1 adds to negative 3. So we'll split up the x's, and then the minus 4 and the plus 1 are in the other two places. Now we look to see if there's any common factors with the numerator and denominator. And we cancel those out. So we have a like factor of x minus 4's. We have another like factor of x minus 2. So what we're left with as an answer is x plus 2 in the numerator and x minus 2, x plus 1 in the denominator. And then the domain restrictions. What can X not be? What would make it undefined? If I substitute 2 into here, or 2 into there, it makes those parentheses 0, which then makes it undefined. So X cannot be 2. Also, if we substitute 4 into here, or -1 into there, it makes either of those parentheses 0. So X cannot be 2, 4, and -1. Those are your domain restrictions. Here's 8.2 day 1 on page 580. Problems 1 through 14.